before we get started, are there questions over the homework?
Oh, yeah, 21.
21? Because I think this is the...
It's the bracket -5, comma, 16, parentheses.
And we want to write it in set builder notation.
Yes.
So this here, we want to write it as an inequality first. So we can draw it as a number line if we want to visually see it. So we'd have -5 and 16. And -5, it would be close, 16 would be open, and we'd fill in the middle. Now, we don't need this to actually answer the question. This is not part of our answer, but it's helping us visualize it. Because we need the inequality. And the inequality is saying 5 is less than or equal to, because we use the equal to sign, because it's filled in. X is less than 16. I did have a student, I think, email me last night and ask about the direction of these, because if we have two endpoints, they're really going to go in the same direction. We're going to have less than and less than. The only time it's going to really change is if we have two separate statements. Then one, yeah, so ors. We'll have possibly two different directions. But any questions on how we got the inequality? We good with the inequality? Now we need to write it as set builder notation. Brace X bar brace. And that's it. So really, this one here, these here, you really just need to get it in inequality form, and then we put the rest of it with it. Any other questions on the homework? Not at this point?
I don't know what my questions are.
Okay.
Did you just go over 26 real quick?
I think that's the set of all real numbers.
The set of all real numbers greater than 19 and less than 32. Is it like that one where it's like 20, less than
20, 32?
Yes.
So we need the inequality first. So we know the numbers are between 19 and
32.
So 19 is
Less than X.
Is less than. So we're good with that. Yes.
Yeah.
Apply our set builder notation to it.
That's it.
Yeah. And I will tell you, number 27, your answer for 27 should look like the start of 20. Mm-hmm. Yeah. So the final answer for 27 that you'll get should look similar to what you started on problem number 20. Except it's not going to have number 4 or have 4. Any other questions? Now, what we're looking at today are parent functions. Now, there's 4 types of parent functions we're going to look at, really 3 out of the 4. Constant functions we're not going to look at too much because it's just a flat line. And any transformation, and really that's what we're going to be looking at, is the transformation of these parent functions, is only really going to move them up or down for the constant function. We can't do really anything else to it. I am hearing things. So constant function is just a flat line. We can only really move it up or down. We can't really change it any other way. That's just what it's going to be. Does that kind of make sense? We can add numbers to it, go down, up. It's a flat line. But the main ones that we really are going to look at, linear, absolute value, and quadratic. Now there's a reason we call these the parent functions. And that is because these are the most basic forms of these 3 functions. Now, I didn't talk about this in the other classes, maybe, or not maybe, because it's above and beyond. And those of you who've had me before, I have a tendency to go into that kind of category on stuff and extend past what we're going to cover, just kind of so that y'all get some background. Because we have more. Because if you talked about, or you remember, stumbling over my tongue, square roots. Remember Algebra 1 doing square roots? Square root of 4 is 2 square root functions. It has its own parent functions. We have stuff that's called cubics, similar to quadratics, but the power is not 2, it is 3. Quartics is 4. Each of these have their own parent functions. That is the simplest version of each one. Now, part of the reason we call it the parent function is because any other linear function is going to look similar to this one. It's just going to be changed in one way or the other. Same with absolute value, same with quadratics. It's kind of the similar that we look like our parents because we came from them. So any of the transformations, any of our other functions are really taking one of these three here for linear, quadratic, and absolute value and making adjustments or transformations to them. And we're applying transformations to them in one way, shape, or form. Now, we're not going to talk too much about domain and range, but if I ask you about the domain of any of these here, hopefully you could get it right. Because hopefully you notice what it says the domain for each one of these is. All real numbers. It's the same for all of them. There's only a handful of functions that the domain is not all real numbers, and that's mainly if we start talking about inverses. Some inverses have some stipulations on them, especially quadratics, or radicals, even roots. Even roots have restrictions because we can't have negatives, so it restricts the domain. And rational, when the variable is in the bottom of a fraction, we're going to have some restrictions. But otherwise, all of these here, the domain's all real numbers. We good with this so far? All right, so we're going to start moving these around. Types of transformations. So we can move them up, down, left, right. We can reflect them, we can stretch them, we can shrink them. Now, linear, quadratic, absolutely. Now, what I'm going to put up here is the general form. Okay. Now, these here are the general forms of linear, quadratic, and absolute value. There's only one other thing that we're going to change or possibly change to them. And really all that is adding in a b value. So I will, especially throughout the year, I will write stuff on the whiteboard, but most likely whatever's on the whiteboard, will write on this screen first. So it'll be mirrored first, and then I might refer back to it throughout the lesson. Okay? Now the location of b is in front of x inside the parentheses. We won't look at it so much today. It has two main functions. One of them is dealing with reflections, and the other is with our vertical or horizontal stretch and shrink. We'll cover those at a later date. But the first one we want to look at in our types of transformations is a translation. A translation is a shift, a movement of the graph, up, down, left, right. It does not change its shape, size, or orientation. We're just grabbing it and moving it around the graph, or moving it around our coordinate plane. Now, if you want to draw arrows, you can. I'm going to list them below. But H, a different color. H is our movement to the left or right. If there is a number in the place of H in any of these three equations, that number is telling us its movement to the left or to the right. Okay? So if we see here, so this h, in all three of these spots here, if there's a number there, a number inside the parentheses or absolute values that's being added or subtracted to x, it'll tell us that it's moving it to the left or to the right. Okay. And one thing to note, if it is inside the absolute values, it is the opposite of what we think. Okay? That's just going to be standard. If it's inside the absolute values, so we're talking about these transformations, it is the opposite of what we think. And it'll make sense, especially when we see it. Okay. K is our up or down. And it's, so if a number is in the place of K, it's telling us how far the function is going to move up or down. Now K is going to be exactly what we think it is. It's going to tell us exactly which direction we go. Inside the parentheses are absolute values. Inside those, it's the opposite of what we think. Outside the parentheses, it's exactly like it is. Okay? Now at this point, that doesn't make a whole lot of sense, but it'll make more sense as we look at this. Now the first one we're looking at is this function right here. G of x equals x minus 4. I will tell you right now, and this goes for the homework too, I do not want you to graph the function or its parent. We're not going to graph them. And part of the reason is the graphing calculators, which you will have access to, and we will go more in depth. We're not going in depth with them today on how to graph it. We'll graph the functions for us. So if we look at, pull this back up, g of x equals x minus 4. What is the parent function for this here? Because is it linear, quadratic, or absolute value? So what's one of the things the absolute value function has? It has absolute values, yes? There's g of x, the one on top. It's linear, yes. And I can use this calculator to graph a linear function. That's its parent function, just g of x equals x. Now the question is, or the part we want to do is describe the transformation. So what's the main thing that's been added to this? The minus 4. So is it moving the function up, down, left, or right? Now the main question, is it inside parentheses or outside? It's outside, yes? So is it taking the place of h or k? K. K's movement's where? Up, down, or left and right? Up and down, yes? So what do we think this is going to do? Minus 4. Down how far? Down 4. Now I'm going to come back here because I can hit y equals, and I'm going to go to the second line and type it in. X minus 4. Graph. Is the new line 4 units down from the original? So it moved it 4 units down. And this is part of the reason we're not going to go in depth, and I'm not going to make y'all graph these, is because we have tools that'll do it for us. So that's it. Questions on the first one? We ready for the second one? So when we look at this here, what is the exponent attached to x? Is there one? So it's understood to be 1. So 1 is linear. If x is to the first power, it's linear. The other two that we have, quadratic, is going to have a square, an exponent of 2, attached to the variable or around the parentheses that has the variable. And absolute value has, well, absolute value bars. Does that answer that question of how we understand that this is linear because it's to the first power? What about this one? absolute value because it has absolute value bars.
I was able to very good.
And then we're in agreement, right one? So is our plus one inside the absolute value bars or outside? So is it taking the place of H or K? H, is it H left and right or up and down? Left and right. So we like right one. Let's graph it. Now, the graphing calculator, unlike the 30XS, will actually do absolute values. To get to it, we hit math, ABS. Oh, helps if I'm actually in the correct spot. ABS, X, graph, absolute value. Yes? Y equals. I'm going to have to do the same thing. ABS, X plus 1. And this is going to move the graph, as we see, 1 unit to the it is left one. Because again, inside the absolute values or parentheses, it's going to be the opposite of what we think. Because it's plus 1, it makes us think that it's going to move to the, but it's actually moving to the. And there's a reason for this. So I'm going to write the general version of this above it. Because inside the absolute values in the general form is what? X minus H, yes? But in our equation, it's not a minus, it's a, what is the only way I can turn that negative or that minus into a plus? Is with another. So really what this is telling us is that this is the absolute value of X minus negative 1. So what is the actual value of H? H is negative 1. So it is a negative value, which means we would move to the left. This is technically the way we would have to look at it and do it, or we can just say, I see X plus 1. Since it's inside the absolute value bars, we're going the opposite of what we think. So instead of going right, we're going. Now, if it had been X minus 1, we wouldn't go left, we would go. It's always going to be the opposite of what you think inside these bars or parentheses. Yes. Questions on this here? We will do more of these here in a minute, but before we get there, we're going to look at reflections. And luckily, I'm not going to make you reflect on these too much. Yes, it's going to reflect across the X or Y axis. Now, for the most part, we're going to mainly focus today on X axis and not Y axis. Partly because I will show you this, especially with the absolute values. Across the Y axis will be in front of the variable inside the parentheses. So we don't necessarily have a spot for it. So earlier when I said we would add a B location or a spot for a variable called B, that would be for reflection across the Y. Now for most absolute value functions and quadratics, just having the reflection across the Y is not going to do a whole lot. I'll tell it to graph it. Did that change it? Technically, yes, but not really. Because all the points that were on the original absolute values function to the right of the y-axis are now on the left. And all the ones that were to the left of the original graph on the absolute value are now on the right. So it just flipped onto itself. So for us to really see a difference, the absolute value or the quadratic function has to get away from the y-axis. Its center cannot be on the y-axis. Otherwise, it's just reflected onto itself. Kind of like when we look at a mirror. It's just a reflection onto itself. The left and right sides flip. And that's all that's doing. But once we get away from the y-axis, then we actually do see a mirror happen. Now, for us, Anyway, we're coming back here. If A is negative, it is a reflection across the x-axis. If A is negative, it's a reflection across the x-axis. No. Now, the y-axis is going to be in front of the x itself. Inside the parentheses are absolute values. So A is located outside. For it to be across the y, it's got to be, I will put a dot on these here. That negative's got to show up here, here, or here. That's where that negative has to be for it to be across the y-axis. Does that make sense? So with reflections, it's not so much the value, especially across the x-axis. It's not the value, the number that A is. It's its sign. If it is negative, it's a reflection across the x-axis. If A is positive, no reflection takes place. It's only if that A is negative. So, look at this first one up here. P of x equals negative x squared. What is its parent function? Is it quadratic? Do we have a movement up, down, left, or right? So up and down is our k, yes?
Yeah.
Do we have a number in place of k? No. No. That was a little bit of a trick because I'm just throwing out that there to see if y'all see that. Because for it to be k, we have to have something added outside the parentheses. We don't have anything added to it. What's the only thing we actually have is the negative. That's the only thing that we have, really. Because the parent function is really just x squared. So the only difference is the negative out front, which is in place of a. So in this case, a is negative, the a value, because we're looking at the a parentheses x minus h squared plus k. Well, a's value is negative. And if a is negative, it's a yes. With identifying these transformations, I would really look, especially if it's starting, I mean, y'all are getting used to these. Be looking back to those general forms. What is taking the place of each of these spots, A, H, and K? If A is negative, it's a reflection across the x-axis. If there's a value in H's spot, it's going to be left or right. If there's a value in K's spot, it's up or down. Here, all we have, A is negative, so it's a reflection. That's it. How about the next one? What's its parent? Linear. Hopefully it's okay. And this one is also a across. Mm-hmm. There's a reflection across the x-axis. Any other questions on these here? We're ready for the next one. Number 2. So these here are just a combination of what we've done so far. So we have x plus 3. What type would this be? Linear. And how is it moving? Almost. 3 is right. Is it inside parentheses? So it would be up, down, In this case, it would be up 3. Now, I didn't say this in the other 2 hours. Technically, left 3 would be right, but not, I would want to go with more up 3. Linear functions are a little bit different that way, if that makes sense. Let's look at the next one. Okay. Yes. So inside parentheses is it taking the place of H or K? So it'd be left or right. I will agree that it is moving 2 units which direction? Right. Inside parentheses is opposite of what we think. Yes. Both. Because, again, inside the absolute values or parentheses is opposite of what we think. It goes for both of them. Because this is also x minus h for quadratics. So it is right. Inside parentheses or absolute values is the opposite of what we think. It goes for both of them. Does that hopefully make more sense? Because looking at this here, the x's matches up and negatives matches up. So the value of h has to be positive 2. Positive 2 is going to be to the right. Hopefully that makes sense. We'll see one more where we're moving left-right. This one here. So it'd be absolute. It would be a reflection. Across. Not too much. We'll get into it a little bit when we apply transformations, but not so much identifying them. Because we have a negative, especially in front of the absolute values or parentheses, it's going to be across the x. Questions on any of this here? We're ready for the next one. Vertical stretch and shrink. If a is greater than 1, it is a vertical stretch. If the value of a is between 0 and 1, it is a vertical shrink. A is greater than 1 is vertical stretch. If it's between 0 and 1, it's a shrink. Now, again, if the A value is negative, the negative has nothing to do with vertical stretch or shrink. It has only to do with the reflection. Questions on this here? So if we look at this first one here, g of x, this would be absolute. It would indeed be a vertical stretch of what? Two. Because vertical stretch, we know it's a vertical stretch because the value of a is 2. 2 is greater than 1. And we define it or kind of describe how much it's being stretched by, we just use that number. Questions on this here? Let's look at the next one. H of x. It is a quadrilateral. Yeah, we want to cross instead of down. X squared. Oh.
Yeah, I was like.
Apparently,
I was like,
I'm in last year's mode somehow. Quadratic. I just called it a four-sided figure. That's funny. So it is a quadratic. Yes. Of 1/2. That's it. Questions on this here?
So it's a stretch.
Parenthesis? Fraction? Yeah, if it's between 0 and 1, it's a shrink. If it's greater than 1, it's a stretch. So if we look at this next one, which is linear, so 3x, the value of a is 3. So this would be a vertical stretch of 3. If you need to go, you can. Yep. So looking at this one here, this is quadratic. It is indeed a stretch.
Oh, yes, it's over.
Yes. Vertical stretch of 3/2. Because they threw that in there just to see if you're paying attention, because it is tempting to want to say every fraction is going to be a shrink. But we need to make sure that the fraction is between 0 and 1 for it to be a shrink. If it's greater than 1, it's a stretch. Mm-hmm. Yes. Have a good weekend. I won't be here tomorrow. So again, if you're having a makeup day, make sure to watch the video for the last set that we're going to do. You should be in here. Vertical shrink of 0.2. What do we think of these so far? Are you ready for the last part? We can do more than one. We can have more than one of these transformations happening at the same time. That's the only thing we're finishing this with. Now, what kind of function is this? Absolute. Part of the reason we know is 1 is a v-shaped function, and 2, we have the absolute value bars. Now, looking at this function, we have 2 transformations. We have the 2 outside and the +1. The 2 is taking the place of a, so it would be a vertical stretch of 2. For it to be a reflection, that 2 would need to be negative, because the negative sign in a's place is talking purely about the reflection. It has nothing to do with the stretch or shrink. The number itself deals with stretch or shrink. It's in front of those parentheses, or absolute values. Yes. Because a, x minus h plus k is the normal form. Because that a has a value other than 1, it's going to have stretch or shrink. 1 is k, which is up, down, and it would be up, one. And that's it. Questions on this here? Want to see another one? Yeah. So linear. Right. So if there's not, so yeah, determining the difference between h and k, especially if there's not parentheses. If there's not parentheses, there is no h. So we would have to have parentheses for there to be an h value. So 5 is linear. So if we look at the exponent on 5, is there an exponent? So exponent would be no. So it's understood to be 1 is going to be linear. On 6, yeah, absolute value will have the absolute value. Quadratic is going to have an exponent of 2.
So for determining a, it would be like +1 or -1 or something like that.
So here we don't have anything inside the absolute value, so there is no h. We only have the k on the outside.
Okay. So there can't be both one thing.
Yeah. We can have h and k.
Is that x function? Just there to
It's there to tell us it's a quadratic. We'll deal more with it when we actually dig into quadratics themselves. So let's look at this one and one more, and then we'll be done for today. Yes, because the number in front of the parentheses is a number between 0 and 1. It tells us it's a vertical shrink of 1/4. Because it's taking the place of A. A tells us vertical stretch or shrink. If that A value is negative, then it is a reflection.
Wait, so h is negative?
H, yes, H is inside.
Yeah, so it's opposite.
Opposite what we think. So it's
Right.
right 3. I am not expecting y'all to memorize these here. I would be referring back to those general forms every single time and matching them up. Because that's going to be the easiest way to keep these straight. Also, you're going to be able to use your review sheet on the test, so you don't have to memorize them. Because even if I don't put them on the review sheet, you can write them on the review sheet. This is the last one we're going to look at. So this is, I will go on and tell you, a quadratic. How many transformations do we have here? Let's start from left to right. What is the first thing we have?
So it's a reflection.
Across the x-axis. What do we have next? Yes, because we've got the 0.25. Because A's sign, if it's negative, tells us a reflection. A's value gives us the vertical stretch or shrink. Does that make sense? So A has two components. It has the reflection if it's negative, stretch or shrink if it has a value other than 1. Now this one here would be a vertical what? Of? And last but not least, in K, which is?
Right.
Up. K is our left and right.
Oh, yeah. H is left and right. Yeah.
Yep. K is our up and down. H is our left and right. Questions on this here? So again, even though the instructions on some of these say to graph the function and its parent function, you do not have to graph any of these. You do not have to graph any of these. Just go on and describe the transformation. Because I think for 1 through 4, or 3 through 5, it says describe the transformation. And you do have the entire class period tomorrow to work on these. Yeah. If you do have questions, especially over the weekend, please ask.